Hello, thanks for checking out this video. In this video I'm trying to share with you some of the progress I've made, minimal as it may be, on challenge problem 6.2. This is actually quite a fun problem. I've enjoyed working on it. In the premise of the problem it says that we're given the ordered pair 7, 29. And then every minute we can create new ordered pairs using one of these three rules. For any x, y you get, you can birth the point x plus 1, y plus 1. If x and y are both even, so if both of the coordinates are even, then you can create the ordered pair which is half of each one of those. And then for any two ordered pairs that exist, x, y, and y, z, you can birth the ordered pair x, z. The question that was asked was, given starting with only the ordered pair 7, 29, can you birth the ordered pair 3, 10? So this is a fun little challenge here. I set up a few things here on Desmos to kind of organize my work. And the first thing I wanted to say was that it's pretty clear to me that we will only get positive integer x, y's. Because given a starting point, first point to work with that is, a set of two positive integers, and using my rule about adding one to each, I know that that rule will only create positive integer new ordered pairs as well. I also know that this rule says that if x and y are both even, then we get x over 2 and y over 2, means that those x over 2 and y over 2 will have to be integers as well. Since the definition of even is that 2 is a factor of the number. And then if these rules, if the first two rules only create positive integer, ordered pairs, then the rule that says any two of them creates a new one using the first element of the first ordered pair and the second element of the second ordered pair, well, that's only going to create a positive integer ordered pair as well. So there's no way to get anything other than a positive integer for both of your coordinates. I created a setup here to kind of organize my thinking. The first thing I thought was that anything that appears along this line, I guess it technically would be array, the portion of this line that where the order pairs are bigger than 7, 29 could be birthed by this rule. By using that first rule, the rule that says that if you add 1 to the x and the y coordinate, you would get an ordered pair along this way. And I even have it set up to show you which ones you can get. I created a list of the even a's. And so all of these ordered pairs are possible. Each of these can be birthed. And so are these. And I'll tell you in a second why I made them different colors. So we can get anything along this way by simply applying that rule of birthing new points by adding 1 to the x and the y coordinate. If I can make 729, I can make 830, I can make 931, I can make 1032, and so forth. The reason I set these up in different colors is that only some of these, though, apply to that second rule. Only the ones that are shown in red and not the first one that I started with. Maybe I should have made that a different color. But only the ones that are shown in red along the way, where both the x and y are even, apply to that second rule. The ones that don't, I guess I should say it this way, since we started with an ordered pair that consisted of two odd numbers, I knew that every other point birthed in this way along this line would create even, even, and even, even apply, then will allow that second rule to apply. So then these points, these ordered pairs, are the babies, if you will, of the red ordered pairs up here. So 8, 30 can give birth with one of those rules to 4, 15. 10, 32 can get 5, 16. 12, 34 can get 6, 17, and so forth. So all of these are possible using those first two rules. And the thing that I'm thinking about is this. I'm trying to see if I can create, I guess I'm thinking of solving the problem backwards. I'm looking for if I can make 620, for example, if I could make, 620, which would be right about here, then I know for sure that I could use that rule number 2, to get 310. I don't see 620 on my list yet, and that doesn't necessarily mean that we can't make it, but that's just what I'm thinking about. I was also thinking about the fact that if I could make 29, 29 would allow me to make 310, Or if I could find 3 comma something and something comma 10, I could use that third rule to create 310. But I think there's an issue. I think there's a problem. I don't know that I can use either of those first 2 rules to create any y value any first order pair that is less than 4. Since the rule for my since that first rule that created these points doesn't work backwards. It's not true that if I can create 729, I can create 628 or 527 and so forth. The only way to get a first coordinate that I'm aware of that's smaller than 7 would be to get to an even first coordinate off of this list, and then use the rule if both of those are even to create something smaller, like we did to get from 830 to 415. So I'm thinking that I can't get to 29 that would allow the first rule to work unless I can find a way to make 4 comma something else that is even. It's worth pointing out that on this list of blue ordered pairs generated by taking half of the red ones, that none of these have both coordinates that are even. 415 has the first coordinate that's even. 516 has the second. 617 the first. 718 the second, and so forth. So I think you can say that none of the ordered pairs on the blue, along the line that contains this blue set of ordered pairs, would generate any, you might call them half babies. I don't think I can use that rule again to create anything else off of this. I also think that it's going to be difficult to find, using this third rule, the rule that says if you have 2 ordered pairs, to create a new ordered pair using the first coordinate of the first ordered pair and the second coordinate of the second to create 310, because I don't know how to create 3 comma anything. So I know I can make, for example, using that third rule, since I can make 415, and I made 1537, I could make 4 comma 37. Be like way up here or so. But I don't know how to use that process to create anything with a first coordinate less than 4. So my instinct is to say that I don't think we can make 310 unless there's an observation that I've not seen as of yet. So I've done a lot of, I guess we would call it specialization, and working with the specifics of a few cases here. I guess I'm struggling now to find a way to attack this in the idea of formal proof. So if you've got some feedback to share with me, that would be super helpful as I try to work on solving this problem. One thing that I think that will be useful is I think I can formally talk about some of the things that I've enlightened to in the video here. Like I think I can show that for a fact that any one of the even ordered pairs, the even comma even ordered pairs along my first line here, their halves create no ordered pairs that are of the form even comma even. But I think that's just attacking at one of the smaller pieces of my problem and not the problem as a whole. So if you've played with this one yet, or even if you haven't, I'd love to hear some of the feedback you have, or if you've been enlightened to something that I have not quite seen yet, I'd appreciate you sharing that as well. Thanks for taking the time to watch this. Definitely intrigued by this. I definitely want to play with this some more and see if this can be solved, and anything you can do to help me push me in the right direction would be super helpful. Thanks for watching. Have a good day.